Hey guys, this is Mr. Sal with another video. This is Module 5, Section 3. Well, it looks like it's just adding mixed numbers. It looks like we'll get to subtracting mixed numbers in the next section. But in any case, looks like we don't have a lot of diagrams for this one, which is okay. Alright? Just remember, the main thing we want to do is change these mixed numbers into improper fractions, add the two together, get our answer, and then change it back into a mixed number, because it looks like they want these to be, the answers to be in mixed numbers. Now we can see method 2 right there. Add the integer values of the mixed number, then add or subtract the fraction to be sure to get common denominators if they're different. I'm going to show that method, but I'm going to show it on the second example, okay? Because if I do it on the first example, it's not really going to help us too much. Alright, to change these into mixed numbers, or these mixed numbers into improper fractions first, we use the cycle method. So hopefully we all remember that. I take the 4 and multiply it by 8. 4 times 8 is 32, but then I've got to add 3 to that to get 35. Now the denominator stays the same in eighths, and both of these are in eighths, so we won't even have to change the denominator once we get that done. Over here the same thing, 2 times 8, which is 16, and then add the 3. 16 plus 3 is 19. So we're adding these two together. Again, we're dealing in eighths right here. And 35 plus 19 would be 54 eighths. Now you could change this into a mixed number right now, but before I do that, I'm going to simplify this because I notice that both of these are divisible by 2, which would give me then, looks like it's going to be 27 fourths. Let me just double check that. Yes, looks like we're good. So 27 fourths, I need to change this into a mixed number, right? So I'm going to take the 27 and divide it by 4. 4 goes into 27. It should go into it 6 times, right? 6 times 4 is 24. So we'll subtract that. We got a remainder of 3, which means that my final answer, the quotient was 6 with a remainder of 3 in fourth value. So this would be my final answer right there. Now that's that first method, and you'll see once we do the second method that it'll be like, oh, that would have been really nice on this one. Doesn't matter, it's going to give us the same answer either way. So, and I do like this method. It's just sometimes it causes us to make some mental errors when we do this. So just be very careful when you do it, okay? So the first thing I would focus on is the whole values, which is 10 and 3. Go ahead and add those to get 13, okay? Now you're going to focus on adding the two fractions. Again, this is separating the problem into smaller, hopefully more manageable parts. And the 13 is the whole value of this. When I add the two fractions, I may have to borrow or carry, if you will. It looks like I don't think we're going to have to on this one, but we'll see. Okay. So I'm going to take 3/14 and add the 4/7. And I got to make these common denominators, right? So to make a 7 of 14, I would multiply those by 2. So now I have 3/14 plus 4 times 2 is 8, and 7 times 2 is 14. So this would be 3 plus 8, which is 11 in 14ths. This is the fraction. Now you'd see if you could simplify this, of course. But this is not simplifiable, so I have 13 and 11 14ths. That's my final answer right there. Now some of you were thinking, wow, that was pretty freaking awesome. I could do that all the time. Alright, if you feel that way, then feel free to do it. Again, just sometimes there's those little mistakes. Sometimes it's within this part right here. Sometimes it's just, well, we look at the 3 and 4 and we add them, we get 7, and we're not sure if it's 14 or 17, okay? And you'll get the 13 right, but we'll miss the fraction. Sometimes it's even this whole value. Sometimes it's Not knowing when to carry, when to move it across. Like if this 11/14, for example, let's say that it came out as 15/14. Well, one of those would have to be changed into a whole, which instead of 13 now would be 14. Okay, so you got to keep those in mind. If the fraction is improper, you have to change it into a mixed number and add whatever whole value you get to the whole value you had. Alright, maybe you guys like that method, maybe you didn't. I'm going to use it again on this one just to demonstrate it, kind of solidify it. Most people do prefer it this way. 1 plus 5 is 6. Now again, this is only addition of these mixed numbers. I wouldn't use this method with the subtraction because it causes even more problems, okay? 1 plus 5 is 6. That's great. But then I've got the 5/6 plus the 1/8. So we have two very different denominators on this. Well, kind of different. And I know that some of you guys are like, man, I know I could use 24, and that's great. But let's say that we didn't notice that. So I'm just going to say, well, they're kind of different enough. I'm just going to multiply the two fractions by the other fraction's denominator. So the 5/6, I'm multiplying the 5 and 6 by this denominator, the 8. And the 1/8 I'm multiplying by this other denominator, the 6's. And what does that give us? Well, that'd be 40 right there. 8 times 5, 1 times 6 is 6. We're going to add those. 6 times 8 is 48. So we're looking in 48ths right now. Specifically 46/48. But this is simplifiable at this point, right? I can divide both of these by 2. So now I've changed this to 23/24, which is very nice. It's almost a full value. So I got 6 and 23/24. And yeah, that can be simplified. So that's the final answer on this one. Alright, now you could use that method on this one. You don't have to. I'm going to use the method where we change these into improper fractions first, and then we'll add them and then change that improper fraction into a mixed number, change it back to a mixed number. So let's get started. I got 8 times 4 to start out with my cycle method, right? That's 32, and then whatever that is, I add the 1. 32 plus 1 is 33, and this is in fourths. So now 6 times 12, it's going to be a big number. 6 times 12 is 72, then add the 1 there, that's 73/12. And yes, both of these are being added to each other. Now I know 12 is a multiple of 4, so I can just take the 4 and multiply it by whatever value I need to get the 12, which should be 3. So now I have 33 times 33, which is 99 in 12ths, which I am adding to the 73/12ths. So what does this give us in 12ths? Well, 99 plus 73, 160, 172. And yeah, we have something that can be simplified at this point. Both of these are divisible by 2. Now, they could be divisible by another 2. I'm not sure yet, but we're going to find out. So 172 divided by 2, that would be 86. 12 divided by 2 is 6. So yeah, this is divisible once again by another 2. So I'm going to divide these by 2, which is going to give me 43 thirds. That's going to be a lot easier when I go to my long division, right? 43 divided by 3. 3 goes into 4 one time, so I'll subtract that out. We got a 1. Bring the 3 down. 3 goes into 13 4 times. 4 times 3 is 12. And now I have a remainder. That's an R, by the way. A remainder of 1. So my final answer on this one, let's go ahead and write it out. The quotient was 14. And again, some of you guys was like, well, I did 8 plus 6, which was 14, and that was awesome. And how many did we have remaining? 1 part out of 3, which, if you took the 1/4 and plus the 1/12, it appears you should have gotten, I guess that would have been 4/12, which would simplify to 1/3. So either method that you use, you should have gotten the same answer, 14 and 1/3. Alright, to start this page off, I'm going to actually start at the bottom. I guess just cause for now, actually. Now you get to choose, again, just like we did on the last one, you can choose whichever method you like. Doesn't matter to me. I'm going to use, on this example, I'm just going to add the whole numbers first. 5 plus 4 is 9. And then I'd have 15/6 plus 7/8. So I'm going to write that over here just so I have a little bit more space. 5/6 plus 7/8, right? Now this one's nice because 16 is a multiple of 8. It's the second multiple of 8, so to change this fraction, I can multiply the 7 and 8 by 2 to get 14/16. So now I have 5/16 plus the 14/16. Now again, this is where we kind of run into some problems here. 5 plus 14 is 19. This is 19/16. However, 19 is going to be a full 16, and how much of that would be left? 3 out of the 16. So I really have 9, and then another 1 and 3/16 is what this comes out to. And I've got to combine those two numbers again. 9 plus 1 is 10, and then we still got the 3/16 right there. That cannot be simplified. So this is our final answer, 10 and 3/16. Now again, this method works really well. This one worked really well, even though we had to carry the 1 over into the whole values, right? We had to combine the 9 and 1. It also worked really well because the 16 and 8, it's pretty easy to find a common denominator when one of the denominators is a multiple of the other one. So keep that in mind when you're looking at these values. Kind of study out the values first to see if one method will work better than the other. If anything, though, the base method for this is the first method. Change everything into improper fractions, find common denominators, add the fractions, change it back into a mixed number. That method always works. It's so consistent that if you can get it down, eventually you'll get this. But that one is so consistent, it works. As far as I know, it's worked for all students. Alright, let's try the old-fashioned cycle method on this one. So, right, I take the 1 and multiply it by the 6. 1 times 6 is 6. And then add the 5 right here. Sorry, that's addition. So that would be then 11/6. And then cycle the 7 and 3/8. 7 times 8 is 56. And then that's a 6 there, plus the 3. So that would be 59/8 right there, which we are adding on this one. Now we don't have common denominators here, but we can find them. Looks like, again, I think we've used this one already with the 24, so I'd take 6 times 4, and I'd have to do 8 times 3 to get that, so we'll do 11 times 4 and the 59 times the 3. So that would be 44/24 plus 59, I'll have to do this one over here, 59 times 3, which is 27. 3 times 5 is 15, plus 2 is 17. So that's going to be 177/24. And again, we're adding these two together. So what do we get? 144 plus 177 should be 200 and, let's see, that's 11, so that's going to be 12 right there. 221/24. And let's see, can this be simplified? It's not divisible by 3 or 2. So no, it doesn't look like it can be. Let's go ahead and divide these up. 221 divided by 24. Looks like it should be... Geez, I think that's 9. 9 times 4 is 36. So we'll have the 3 there. 9 times 2 is 18 plus 3 is 21. So yeah, it looks like that's it. We're subtracting this, which appears to give us 5 remaining. So this would be 9 with a remainder of 5 out of 24 parts. That right there is the final answer. Alright, this one I'm going to use the second method, so no cycle method on this one. Probably not the next one either. But I'm just going to take the 5 plus the 2, which would be 7, and then the 2 fractions, right? 7 ninths plus 5 ninths. And yeah, I'm using this method because the denominators are the same, which hopefully you noticed when you started this problem. And 7 plus 5 would be 12 in ninths right there. This is simplifiable by 3 on this one, so I'm going to divide both of these by 3, which would give me 4/3. Now this one's pretty easy to change into a mixed number. That would be the same as 1 and 1/3. So my final mixed number is going to have the third, but I'd have the 7 plus the 1, which is 8. So my final answer here is 8 and 1/3. Now this problem is going to be like the last one. We're going to have to do some carrying on this one. So I'm going to take the 2 and 4 and add those together to get 6. And then I'm focusing just on the fractions, right? 8/11ths plus 5/11ths. And this one's nice because the denominators are the same. 8 plus 5 is 13 in 11ths. This is not simplifiable, but I know 13 will go into 11 one time, which will give me a remainder of 2. So I have the 6 and also the 1 and 2/11ths. We are adding these together. So the 6 plus 1 is 7, and then I've got the fraction left over, 2/11ths. And this is our final answer. That was pretty nice. Those last two were pretty good. So hopefully you found a method that you liked. Again, if you find that you're adding 2 mixed numbers and the denominators are the same, I really like this method. If not, I mean, I still like it. It's just this method here is very durable. It's very consistent. So if you like it, please use it, alright? Alright, well that concludes this lesson. Thanks you guys. We'll see you in the next one.